Welcome to this presentation on Solid Edge modular plant design. I hope this presentation will be interesting, informative, thought-provoking, and allow you to think about your own company processes in a different way, to see the benefits of digitally transforming and automating your plant design workflow. My name is Graham Berry. I am the Siemens Business Development Manager for EMEA for Solid Edge modular plant design products. I'll be taking you through this short presentation. I'll then be joined by my colleague Paul Abbott, who will take us through a short demonstration of the solution in action. Here is our agenda for today's presentation. We will look at the trends and challenges that are facing the industry today, how intelligent solutions in modular plant design are helping to meet these challenges. We will take a brief look at how Siemens are responding to the challenges and the capability that exists today with Solid Edge. I will take you through an overview of Solid Edge modular plant design, its capabilities, business value, and a case study. And finally, I hope to have time at the end of today's session for you to ask any questions regarding what you have seen. It is clear that over recent years, the process industry has moved away from large-scale, on-site construction, which has been slow, costly, prone to errors, and late on delivery, to an off-site modular design and construction, allowing for the build to take place in a controlled environment, lowering the scrap, increasing the quality, and allowing for a concurrent manufacturing process, which significantly reduces the time to commission the plant. As Stuart Harris of Emerson recognises, digital transformation doesn't have to be complex. The right approach can ensure technology investments deliver the results that matter, with confidence, ease, and speed. The process plant industry has followed the building industry to a modular design, here shown as a skid. The skid, in turn, can be part of a crash frame, which can be stacked one on top of another, or the skid can be put into a container, used on board a ship, oil rig, or other harsh or hazardous environments. Typical industries that we work with are energy and utilities, industrial machinery, and food processing. Within these industries, there are additional focus areas, and it is true to say that any piping requirement can be handled with Solid Edge modular plant design software. What we are seeing is that the industry is really driven by the need for bespoke solutions for you and your customers. Or as we might say, a product that is engineered to order, or ETO as it's referred to. In this area of ETO, our modular plant design solution will allow you to obtain higher efficiency of your skilled engineers and capture best practice amongst many other business benefits, which we will cover next. Tech Clarity Research recently undertook a survey of companies to see how they performed in 7 key areas. What was observed is a gap between the high-performing companies in blue on this chart and the general market shown in red. Here on the left of this slide we can see the key areas that makes a top-performing company. Solid Edge modular plant design will help you achieve these objectives. This is what Siemens calls digital transformation. Welcome to Siemens Accelerator, the foundation of our strategy that enables digital transformation for you. With a comprehensive digital twin at the core, design, realize and optimize. Model-based systems, collaboration and analytics create the unique digital fabric, getting you to the future faster and predictably. Accelerator is all about accelerating that whole process, of course. If we look at the area of mechanical design, this is where Solid Edge modular plant design delivers real value. Let's take a closer look. This slide shows you the depth and breadth of the current Solid Edge portfolio. If you look at the solutions highlighted in black, these were all launched in the last few years, so a huge investment from Siemens into Solid Edge. Note that the P&ID design and piping design are the modules that go to make up Modular Plant Design Suite, and they sit in the first column, Mechanical Design. I will explain a little more about P&ID design and piping design now, before we see a demonstration of them in action. Here we see the overview of the modular plant design workflow. Working from the left of the screen, where we create intelligent 2D graphical and most importantly non-graphical data of the plant process equipment. This is really the master document in which we design our process plant by positioning pipes, valves and equipment that will meet the design specification. This is piping and instrument diagram, also known as P&ID. Most other systems just have this as a dumb 2D drawing. Here with modular plant design we start with our pipe specification, which in turn selects and ensures we use the correct symbol libraries for the specification and standards that we need to adhere to in the design. There are many tasks that are automated at this stage, and there is a high degree of flexibility and customization here too, if that is needed. But if the workflow is well defined, this can be locked down, so this makes it very easy for new users to become efficient and productive. For example, the 3D component models used in the digital twin are derived by the 2D schematic symbols that were used in the P&ID. In some cases you may have options, and the buyers, for instance, may identify a different supplier's component to be used. It's here we can generate reports and bill of materials based on the P&ID data, and these reports can also be customized to put as much or as little data as required in. We now move to the next stage in the workflow, where we start to build the 3D model or the digital twin. Here we will place all of the equipment into the design envelope or 3D space we have been assigned. The focus here is to ensure the equipment such as valves can be accessed easily, and as a result the system determines the pipe lengths automatically. Once all the items have been placed, we can again generate a report including the bill of materials or BOM, and we can then move into the automatic generation of the manufacturing drawings, or isometrics as they are known. Here is a schematic layout of the software modules that go to make up the Modular Plant Design Suite. On the left is P&ID Design Module SE397. On the right is Piping Design Module SE398, which incorporates the ISOGEN isometric drawing creation software. Note across the top where we have our pipe spec, P&ID symbol library and 3D piping library that all communicate together, allowing for a high degree of knowledge capture and automation, so reducing possibility of costly errors. Let's look at the P&ID design module in a little more detail. Solid Edge P&ID design includes 2D workflow and symbol support for P&ID creation, supporting governing requirements for modular plant design. This tool makes it very easy to design across multiple sheets and allows for quick design changes and revisions. 2D P&ID diagram design with built-in symbol libraries can be used standalone from any 3D CAD system or integrated into Solid Edge piping design. The P&ID module comes with a large symbol library out of the box. Here are some of the key capabilities of Solid Edge P&ID design, such as support for industry and company standards, automated lists, reports and bill of materials that are accurate, fast to generate and professionally presented. Bidirectional cross-highlighting between the P&ID and the digital twin allows for the fast identification of items within the design, say for a design review with your customers. Here we look at the Solid Edge Piping Design module SE398. It provides automated 3D piping design with comprehensive 3D part libraries and fully automated isometric drawings for manufacturing. Automated 3D piping design allows faster packaging design. This is key when we respond to our customers that require more detailed quotations and helps win more business. Both the modules mentioned here can work with your existing CAD system or with Solid Edge. Fully automated isometric manufacturing drawings using integrated STAR-CCM functionality allows for fast, accurate production of drawings to be created in many formats and sent direct to the fabrication team. Here are some of the key capabilities of Solid Edge piping design. You focus on the design requirements and don't worry about pipe lengths. These are captured for you. Flange, bolt, washer, nuts and gaskets are placed automatically for you, dependent on the specification you originally selected. Your initial design intent comes to life in the 3D space. Your customers will better understand what will be delivered, and the workflow delivers a highly cost-effective solution that helps you win more business. Additional capability of this solution is that you can also run cable trays, ducting, heating, ventilation and air conditioning within your model. When used in conjunction with Solid Edge CAD system, you get automated 2D drawings. Modular plant design libraries integrated into the backbone of this suite of tools is key to the huge savings in time and money with the elimination of errors on constantly inputting data. The ability to copy a complete library and make global changes to make a new library or standard. From specialized metals all the way to plastics are all catered for. Standard parts or bespoke, engineered to a special order, the system has this level of flexibility when needed. Additional capabilities include working with massive models with ease, patented technology with Solid Edge synchronous design, express route for fast 3D piping route, Solid Edge structural frames with industry standard sections, and there is more. We have additional capability where and when it's needed, from stress and flow analysis, electrical design, requirements management, data management, through to technical publications for those on-site maintenance manuals that your customer will need in a professional and easy to follow form, just as this customer needed. This is Casper Schultz, who design and manufacture brewery equipment based in Germany. Whilst their challenges were identified as having multiple softwares within their design and manufacturing process and having too much manual input, they realized this was slowing them down and introduced errors into the process. Solid Edge modular plant design with, in this case, some pipe bending and sheet metal cutting software allowed them to compress the time to market by 30%, increased the quality of their deliverables to the customer, and allowed them to grow their business. It's time we took a look at this solution in action. At this point, I would like to hand you over to my colleague Paul Abbott to give you a quick overview of the modular plant design in action. Over to you, Paul.
Thanks, Graham. Hello and welcome to this webinar. Today, I'm going to be demonstrating Solid Edge modular plant design, emphasising a lot of the points that Graham has made during his presentation. And to do this, I'm going to be using a simple vapour recovery system. I'll start off showing the intelligent P&ID diagram and making some changes in there. Then I'm going to link this through to the 3D CAD model and show how we can generate the automatic piping in there. And then I'm going to finish by creating the isometric drawing or manufacturing drawing for fabrication. So let's go and get into Solid Edge. Solid Edge modular plant design solutions speed the creation of intelligent P&ID schematics and 3D piping models, ensuring that they are designed right first time, every time. Notice the modular plant design tools provide an engineer quick access to the tools for piping, P&ID schematics and the creation of isometrics. We can begin this demonstration with the 3D assembly of a plant design. To access the related 2D P&ID schematic, simply select to open it, as well as the handy to-do list from within the piping dialog. The to-do list provides valuable feedback on what tasks need to be completed. The to-do list is configurable. For example, changed from a single list of components or filtered by component type, making it easier to find the things you're looking for. More importantly, it supports cross-highlighting in both environments. Selecting an object will highlight in both the 3D model and the 2D P&ID, as we see here. For now, let's focus on the 2D P&ID schematic of our piping system. A nice feature of Solid Edge P&ID is the built-in report capability, so it's easy to keep up with all the information such as component lists and diagrams. Adding components to the design is made easy by leveraging the built-in database, which is preloaded with all the required standards for P&ID creation and which supports strict governing requirements for plant design. Unique tag numbers can be used to fully define any components in the diagram, as well as any other characteristics you may want to add. Adding a pipeline is also a simple task. First, you create the 2D representation of where the pipe will reside. In our example, a pipe from the tank to the pump needs to be drawn. Once created, the pipe spec and size can be defined. One advantage is this information is extracted from the database, taking all the guesswork out. All common standards are supported. After placement, the component tag can be moved and rotated to help create the schematic you need. When placing components onto the pipeline, such as this valve, an option to place from specifications ensures we get the right size. Also, they rotate automatically to the correct direction once placed. Of course, any fine-tuning can be done to the schematic very quickly. As mentioned earlier, to communicate manufacturing information to downstream systems, lists and reports can be automatically generated for the drawing. This could be a bill of materials, which you see here, which sums up all identical components by its article number, or a component list which analyses components by tag numbers. Also, to aid this process, intelligent PDFs can be created. This PDF includes the cover and index page, along with the rest of the information created. Along with the visible geometry, also the component properties are communicated in the PDF. So it's an intelligent PDF that can be consumed by anybody capable of opening a PDF file. Now that the P&ID has been changed, we can go back to the 3D Solid Edge environment. The to-do list illustrates the changes that need to be implemented in the model based on the updates to the P&ID diagram. Simply refresh the to-do list and any changes that were made are highlighted in orange, as we see here. The first step here is to get the new pump placed into the Solid Edge assembly. 3D parts are placed from the standard parts library and component properties from the P&ID are automatically assigned. For this pump, we can simply select graphically where we want it placed in the assembly. Another great feature is the ability to show the from-to points of a defined piping path. Clearly identifying these points makes it easy to define the appropriate 3D piping path to ensure it avoids any clashes with other parts. These points can easily be turned on and off at any time from the to-do list. Once the path location is understood, it's time to create the path. First, a subassembly is created to store the piping information, and then we'll go into that new subassembly. Then we can use the routing tools to enable us to automatically create a route from the 2 points highlighted earlier. One advantage to using this quick routing tool is it gives the user quick select options to get the most efficient path for the pipe route. After the path is created, it's as easy as toggling through the different path options and selecting the most effective one that fits the occasion here. Now that the path is created, the to-do list makes it easy to assign all relevant information from the P&ID to the pipeline sketch. Simply use the assign option, select the path, and Solid Edge will automatically pull the information from P&ID to create the correct pipes. Again, taking the guesswork out of the equation. Now remember, we created a valve in the P&ID diagram, but we now need to place that. We use exactly the same process as when the pump was placed. The valve information gets extracted from the P&ID, the correct valve is selected from the 3D standards parts library, so we only need to place it into the assembly. When placing components in the assembly, you still use standard assembly placement tools that you already know. So no need to learn anything new to do this. Once placed, a simple recalculation of the route automatically adjusts the pipes and places any additional flanges and gaskets as required. Notice the to-do list shows all the components now up to date, i.e. they're all in green. Isometric drawings of the 3D pipelines can be quickly and easily created. For example, we will focus on the pipeline that we just created from the Modular Plant Design toolbar. The isometric command can be started. It will gather all the necessary information, which is automatically taken from the 3D pipelines just created and is used for generating the isometric drawing. The interface offers a few different options, but the final result is this case, a Solid Edge draft file that contains all the appropriate information required for the manufacturing of this pipeline. All we have to do is open the drawings to review them. And there it is. So there you have it. Solid Edge modular plant design solutions to help you speed up the creation of intelligent P&ID schematics and 3D piping models. So we had a look at intelligent P&ID diagrams. We had a look at using libraries of symbols, design rule checking to ensure accuracy. We showed the intelligent PDF generation for downstream collaboration, design reviews. Then we showed 3D CAD. That showed the link to the P&IDs, ensuring that the parts all fit together, making sure there's no clashes. And then we showed the auto pipe routing and clash detection. Finally, we created some isometric drawings showing parts and components lists available for downstream fabrication. So, back to you, Graham.
Thank you for that, and I would just like to take you through two final slides to remind us of what we have seen and some of the benefits of why we should invest in this technology. This is a database-driven solution. It reduces human error, speeds up the deliverables, makes our output consistent and of high quality. It ensures we adhere to standards and increases both the quality and also the speed of communication, whether that be within your own company or with our customers or to gain new business. Our projects will be more complete, capturing valuable knowledge along the way, allowing us to be more flexible in suppliers, control costs and win more business. We know by using this system we will comply with the ever-increasing standards, meet compliance and traceability requirements that our industry requires of us. It will allow us to fabricate our designs accurately, even if this is done at one of our suppliers. No more nasty surprises. This brings us to the end of today's presentation. It just leaves me to thank you for your time and your attention during this session, hand you back to our hosts and open this up for any questions you may have at this stage. But I would like to invite you to reach out to us so we can better understand the challenges you have within your own business today, so we can better advise you. Thank you. Finally, thank you.